Good afternoon, everyone. My name is Florencio Reyes Jr., and on this episode of Tech Talk, I'd like to briefly discuss with you revolutionizing medical training with advanced simulators and educational strategies. Disclaimer here, this presentation is provided for information purposes only. The views expressed herein are my own and do not represent those of the Departments of the Army, Air Force, Navy, or Department of Defense. I have no conflicts of interest or financial relationships to disclose. The brief outline for this afternoon's discussion, we'll discuss briefly the role of medical simulators, technological advancements that include high-fidelity simulators, virtual reality and augmented reality, artificial intelligence and machine learning, remote and online simulations, evolving educational paradigms that include interprofessional education, competency-based education, and scenario-based learning. And finally, we'll discuss future directions that include integration with real patient data, advanced haptics, and tactile feedback, along with a few global collaboration platforms. So to start off in our introduction here, the revolution in medical training and simulation is driven really by advanced simulators and innovative educational strategies. This presentation explores the impact of these advancements and evolving educational paradigms on the future of medical education. So first off, the role of medical simulators here, as we all know by Webster's Dictionary, a simulator is a device that enables the operator to reproduce or represent under test conditions phenomena likely to occur in an actual performance. While a simulation is the artificial representation of a complex world process with sufficient fidelity, with the aim to facilitate learning through immersion, reflection, feedback, and practice minus the risks inherent in a similar real-life experience. But however, we already know the most important part of medical simulation is really reducing medical errors and improving patient outcomes. Now, to kind of give you a little bit of historical perspective, we know the evolution from basic anatomical models to high fidelities, it has been around for centuries. Although we already know simulation-based type training in healthcare has grown exponentially in the 21st century, all right, we see it happening centuries ago all the way up to where we are today. While in contrast, while it has been employed for centuries, many quality and safety issues still persist today. This is actually demonstrated by the fact that approximately 1 in every 10 patients worldwide is harmed during their care in a hospital in high-income countries, where 50% is preventable. The further irony is that simulation has been underutilized in medical education or training despite ample evidence that the amount of preventable errors and harm for medical care makes admissions to hospital many more times dangerous than air travel. That's kind of an interesting fact when you think about the big scheme of things. On this slide and before you right now, is basically key events in simulation, past, present, and future. Now, we can go back many, many years ago where they actually found stone carvings of human form dating back between 24,000 and 22,000 BC. In 1900 to 1600 BC, Babylonian clay livers were discovered and believed to be used to determine the outcome of illness. In the 6th century BC, Lao Tzu wrote about automation machines, which he described as being made of wood, leather, and glue that could walk, sing, gesture, and wink. If we even go back, if we go a little bit sooner, we look at Hippocrates, the father we all know as the father of medicine between 4060 and 367 BC, suggests that simulations should focus on practicing training of health professionals. All right, between 385 and 322 BC, the Greek philosopher Aristotle taught the importance of repetition in developing expertise and the necessity of feedback and guidance, emphasizing the need for training models. If we go into the Song Dynasty in China between 960 and 2079, physicians used life-size bronze statues to teach surface anatomy and acupuncture. These simulators had organs and holes for needle insertion. The Qing Dynasty used female figurines carved out of ivory to meet the needs of male physicians who were not allowed to examine women. At other points in history, human dissections were not accepted and made illegal by the Catholic Church. However, in the 16th century, Andrea Vesalio sparked interest in studying anatomy. So we see many times throughout history where simulation actually played a role. And although we've been growing in medical simulation through history, Owens actually explained that the 20th century was not expedient in simulation advancements. He referred it to this period as the dark age for simulation. Right? It basically meant the period depicts the time at which the patients were used to practice skills and not from some sort of viable simulator. As some of us might know, in the 1960s, Resuscitation was developed, which revolutionized the ability to train at low cost yet effective model. Around the same time, simulators known as Sim1 was developed, which was which was a sophisticated mannequin with the ability to breathe, had a heartbeat, a pulse, blood pressure, and mouth movements. During the 1960s and 1970s, the Harvey simulator was developed, which was a cardiology patient simulator with a hybrid task trainer and a computer-enhanced mannequin. So moving forward to today, we know that there have been many technological advancements with the increased high fidelity simulators that we see, whether it's high fidelity simulators, whether it's VR and augmented reality, or even artificial intelligence and machine learning. Now, as we see with advanced simulators, some of the high fidelities, and many of us know or have seen or have interacted with many of these advanced high fidelity simulators. Um, they're lifelike with advanced physiological responses that a lot of people really like. Um, Integration of features like breathing, bleeding, pulse simulation, uh, medication recognition. A few of those examples that we see that are very much in play in today's simulation world, for example, is the SimMan 3G, which many of us are familiar with from Laerdal, or the HAL S5301. That's an advanced clinical model that just recently came out not too long ago from Gamar that has some very interesting um, advancements uh, really geared towards critical care. And then, of course, the Leonardo, which was another high fidelity simulator that was from a very small, starter company that has not really been around as some of the other larger players within simulation, uh, from a company known as MedVision. Now, with virtual reality and VR and augmented reality, we already know that there's a lot of immersion training environments that are available in today. We already seen a lot of VR headsets and AR overlays for enhanced interactive learning, real-time feedback and customizable scenarios. And a lot of people, although this is in its infancy, has really taken off and able to allow personnel, organizations, departments to really customize what they're doing. Some of the case studies that we see the Oculus VR in surgical training, or even the HoloLens for anatomy visualization and remote assistance. So we're seeing these really come out to play. Many of us have seen a lot of the VR and AR in a lot of these larger conferences, like for example in the EMS World Expo, or even in some of them like SimOps or SimGhost. We've seen a lot of these items available for not in use. Now, what we're starting to see really a lot more of is the artificial intelligence and the machine learning. So artificial intelligence is incredible, and it's really not that old. And this is one, and many people actually say this is really the future. And right now, we're already seeing how fast artificial intelligence and machine learning is really taking hold of the simulation world. So we already know that typically with AI and machine learning, personalized learning experiences can really do that. With AI, though, we have driven analytics that we can use to tailor training for specific personnel or groups, departments, hospitals, um, predictive algorithms to identify areas that need improvement. Okay. Where we have adaptive simulations that have dynamic scenario and adjustments based on the learner's action. So whether this person is end up, you know, having a little bit of difficulty in some areas, these devices can actually tailor the scenario to allow this person or whoever it may be uh, to actually repeat whatever it may have where they were actually having difficulty, but at the same time, it's gearing the training to allow them to be successful and to move forward. We also have enhanced decision making and training through complex and evolving scenarios for these adaptive simulations. Because again, not everyone operates on the same level. So we need these adaptive solutions to allow each person to move forward and essentially put it on their level to move forward and to become more successful, not only in simulation or with the simulator, but obviously in real world applications. Now, when it comes to remote and online simulations, we do have several options that are available to us. Like for example, with the accessibility and flexibility, we definitely have some cloud-based platforms that allow for remote participation, and this is becoming very, very popular. And we actually saw this happen and really take hold during COVID-19. So as we look, some of the cloud-based options that we potentially may end up having, like for example, Sim University at a distance. This initiative is by the Society in Europe for Simulation that basically transformed their Sim University competition into remote simulations using Zoom. Or we can take a look at other areas like in silico trials, which is a Netherlands-based company that offers a cloud-based platform for the digital simulation and testing of medical devices and pharmaceuticals. Another one that some may be familiar with is Simulation IQ, which is in part of the enterprise cloud. This solution is by EMS, allows educators to manage simulation training environments without costly hardware investments or really paying a ton of money for equipment. And basically, it runs really on Microsoft's Azure framework and really supports clinical simulation activities in simulation centers, actually. Then, of course, some of us may be very familiar with iSimulate, which is a high fidelity medical simulation platform for creating realistic patient monitoring scenarios. And of course, a lot of that is also based off the Microsoft Cloud. So there are several options out there for us to use. We also have other areas like, for example, MedsBlah, which is a platform that offers virtual patient cases, allowing healthcare professionals to practice clinical decision making and communication skills remotely. SimX, that many of us are familiar with, that provides virtual reality medical simulations, allowing users to interact with realistic patient scenarios. And of course, others, for example, like touch surgery. While not exclusively cloud based, touch surgery offers a mobile app with step by step surgical and simulations. And users can practice these procedures remotely. We also see these remote and online simulations was really kind of influenced. As we all know, during COVID-19, we saw a huge surge in online simulation adoption just because of the restrictions that came with COVID-19. However, long-term integration into standard protocols really is kind of the standard these days, where we have the opportunity to use more cloud-based and more remote options that really can be taken and put it on really kind of any platform, whether it's or any device for that matter, whether it's tablets, computers, you know, mobile phones. It's a variety, and honestly, I believe that this particular these online platforms, these platforms, are really here to stay and are really becoming part of the revolution as we evolve through simulation. So, what does this take us as far as education? Well, we already know there's an evolution of education paradigms. We already know this. And three of them that I mentioned earlier on in the outline was interprofessional education, competency-based education, and scenario-based learning. Now, with interprofessional education, though, there's many options for everyone to have when it becomes when it comes to interprofessional education. For example, collaborative learning. Um, for many years, it was the expectation that individual groups would learn together. These days, that's no longer the case. Now we can look at simulations that are designed for multidisciplinary teams, like, for example, doctors, nurses, paramedics, where we get all these teams together and we work as a team to one, not only to understand what we do, but each what each group does, but focuses on the communication, the coordination, and really teamwork. Because let's be honest, in the big scheme of things, when it comes to patient care, it is a team effort. It's not just about one person overseeing the patient's care. We can also end up seeing this where this became a huge, huge piece when it became to ICTLs and interdepartmental training, where we had options where, for example, soldiers for ICTLs, prior to deployment, they have a certain amount of skills that they should be competent in prior to deployment. Or uh, for example, other skills where they may not have too many opportunities or enough opportunities to do certain skills that they really don't have time for or have not been exposed to. But with the interprofessional education side, uh, we're giving them opportunities. And with the various platforms that are out there, those type of skill sets can be improved throughout. Some of the benefits for interprofessional education we already know is it improves understanding of each professional's role, because that's important. If I know what a doctor's supposed to be doing, or if I know what a specific nurse should be doing, or what they know what I'm supposed to be doing, that is always a win-win because we understand each other's skill set, and we work together as a team to provide much better care and much better patient outcomes. Enhanced patient care throughout the collaborative process is, as I mentioned just previously, is an incredible is incredibly important these days on how we move forward with any type of healthcare or any patient interaction these days. Now, with the competency-based education, again, this is very interesting because we can also use uh, as an assessment and certification sides. Like simulations can be used for evaluating clinical competencies. And this is huge because we want people these days, for many years, uh, people were so used to just talking about specific scenarios. With again, when it comes to high fidelity mannequins and the ability to have whether it's low, medium, or high tech task trainers, we have the ability to simulate that. And what we mean by that is instead of talking about what you're doing, we want you to be involved with. We want you to get your hands in there. We want you to build that muscle memory because we already know there's plenty of studies out there that already discuss that when we become stressed, our cognitive ability and our motor movements decrease. Therefore, as we continue to practice in these safe environments and put a little bit of that positive stress on someone, when it comes into the real world and those stressful events hit, we have a much better opportunity for a better patient outcome. But simulation used for evaluating clinical competencies is huge. That way we can see whether or not, where they're potentially having difficulties or where they really need to say, hey, yes, you're doing fine here. We need for you to maintain that skill. We also look at it from a competency-based side is objective structured examinations. Many of us with many of us are probably very familiar with these type of exams. We see them in medicine, physical therapy, nursing, pharmacy, dentistry. Everyone has these potential tests, but how do we get better with that? And then, again, that is simulation. And it really, in this particular case, competency-based education, it's life learning because, as we all know, many things that we used to do years ago really don't really apply to what we do today. It formed a foundation, but as with any medical procedure or potential interaction with patients, and as you know, as our ability to improve healthcare uh, advances, we know that we have to constantly keep learning. We have to constantly get better at what we're doing. And we actually, through regular simulation based training and through that lifelong learning, we can keep our skills fresh. We can, integrate new techniques and new strategies that we have seen and put them into our own wheelhouse. And of course, obviously apply them to real world applications. From a scenario based learning, me personally, I love scenario based learning. And why? Because really There really is no limitation to how far you can take this. Realistic clinical scenarios that reflect real life medical situation emergencies. Some of us, based on where we're at clinically or where we spend our time clinically, sometimes we don't see specific patient scenarios or patient interactions that our colleague may see on a regular basis. This allows us to become very basic when we're starting off with scenarios, or we can make this as challenging as we want to. From, for example, in a critical care based scenario, how we actually manage someone in a more advanced condition. We use the use of patient narratives and history of contextual learning, especially the narratives and the histories of these patients. They allow us to mentally think about how we need to approach this patient. What kind of treatments do I need to think ahead? What type of, you know, issues that we potentially have to think ahead of time to actually allow us to have a much better patient outcome. Allows us to, obviously, in this particular case, it allows us to critically think and really kind of improves our decision making. The emphasis on diagnosing, treating, and managing patient care in a dynamic situation has become incredibly important these days. Simply because, let's be honest, um, in the medical world, we have there are many people outside of the medical community that sometimes have what I would consider kind of a skewed expectation of of medical personnel or clinical personnel for that matter. Sometimes we get so caught up in doing something like this that we forget that we are human. Although our goal is to make sure that we have really good patient outcomes, but however, to be able to do that, we must train to prevent those potential mistakes and potential medical errors. So, where do we go from here? The future of medical training will continue to be shaped by technological innovations and evolving educational methodologies that do include integration with real patient data. We need that real patient data to really kind of put all the pieces together. Advanced haptics and tactile feedback, we see a ton of areas that we see this, whether it's through VR, whether it's through items like, for example, the HoloLens, or even the Tesla suit that really gives this, those tactile feedbacks and those advanced processes that we can see. For example, another tool that is really fast and upcoming is a device by Symbiotics called the Ultrasound Mentor. That's incredibly uh, advantageous to those that have never done ultrasounds, and it's a variety. If you personally, if you've never seen that device, I highly recommend that you take a look at that device. I will tell you right now, it will actually blow your mind the ability that this particular device has to allow our clinicians to become much more proficient in ultrasounds of all different types, whether it's male, female, whether it's EFAS exams, whether it is, ultrasounds on children, those type of things, even, um, pregnant females. It is an incredible device to actually learn how to do ultrasounds in a very safe environment. Um, and of course, we already know that global collaboration platforms are out there, and we are actually embracing that a lot more these days. For example, if you look at some of the global platforms that we have out there, Gaia X, which is a European initiative that promotes health data sharing and emphasizes community-driven development and innovation. You have European Health Data Space, or better known as EHDS, which is a framework for sharing health data across Europe. Health Outcomes Observatory, better known as H2O, a platform for monitoring health outcomes and sharing insights. We may end up some of the collaboration software that we may see out there, SaaSworthy, which provides a list of top-rated healthcare collaboration software. Capterra, which features collaboration tools um, that they use in the healthcare industry, including communication management and even some of the global health partnerships that we see out there, like Doodle Insights highlights that need for greater global public health partnerships in light of the COVID-19 pandemic. So There's a ton of options out there, and I will tell you the future of simulation is very, very bright. Right now, I honestly believe that the future of simulation is really limited to only what our minds can really come up with. But the future looks bright, and we look forward to it and really trying to embrace it. All right. Again, with the integration with real patient data, we see it does enhance the realism. Potential research applications when it studies the impact of different interventions on simulated patient outcomes. As I mentioned earlier, typically the advanced haptics and tactile feedback, we can see those touch sensations, as I mentioned earlier, the Tesla suit or the haptic VR. We also see some very interesting surgical trainers out there um, that enhance the realism of procedures requiring motor skills. One of the common ones I hear a lot of people talking about is the Da Vinci 5 surgical trainer, which is really, really a nice trainer that I've been told by many, many surgeons that have actually used this device, training on it prior to the prior to their real interaction with the Da Vinci. Again, of course, finally on the global collaboration platforms, as I mentioned, several of them already. We really it's an adoption of advanced simulators and educational strategies that really have a global impact. It is global out there these days. It's not just about the United States. International training team, simulation, uh, training programs, standardization of practices is really what's nice about out there. So everyone can get on the same page when it comes to collaboration. But these advancements do bridge educational gaps and enhance the healthcare outcomes. So in conclusion, guys, the integration of advanced simulators and educational strategies is revolutionizing medical training, elevating the standard of education and preparing healthcare professionals. Um, However, we need to embrace those advancements. Um, that it is essential for shaping the future of medical education. So here are my references. Please feel free to download them and read those references if you like. If you have any questions, by all means, this is my email address. And I really appreciate you hanging out with me today and hearing this brief about, the evolution of medical education and simulators. So thank you, and we'll see you soon.